Okay, for question 3, a car of mass 800 kg is pushed with a constant force of magnetic of 200 Newton for 10 seconds. The car starts from rest. Resistance to motion may be in note. Okay, find its speed and the end of 10-second interval by using A, by the impulse of the car, B, by Newton's second law. Okay, so for first part, A. Okay, by impulse, we know that the impulse will be equal to 200 Newton, adding on for 10 seconds, right? So you have 2000 Newton second. Okay, so you know that the car is start from rest. The changing of momentum will be mv, okay, minus mu. So u is 0, so that you know that mv is equal to 2000. Right, so v will be equal to 2000 over 800 is equal to 2.5. Right, so v is equal to 2.5 meter per second, the speed. Okay, so this is by using impulse. Okay, so by part B, they say ask you to use Newton's second law. Okay, F equal to ma. Let me remove the part first. Okay, if F equal to ma, 200 will be equal to 800 A. Right. Uh, so A will be equal to 0.25. So the force is constant, assuming that. So V will be equal to U plus AT. Okay, so you will get 2.5 also, right? So they have the same solution for you by using the kinematic and impulse, right? So part 1B. Okay, part 2, comment on your answer to part 1. Okay, so part 1, both, you can say that both methods give the same answer, but the method based on the Newton's second law and the constant acceleration formula only works because the force is constant. Right, the force is constant. Right, if the force is not constant, then we cannot apply that one. Okay, so all the things that on top will involve the constant force, so that you can apply the Newton's second law by assuming that the force is constant. Okay, so that you use the constant acceleration formula. Okay, so if you know that the force is constant, that you always can say that the F equal to ma. Okay, or maybe you can say m equal to dv dt, is equal to m dv dt. Okay, so if you want to separate this by two sides, okay, until certain time, f dt. Okay, we assume f is constant, and m, you integrate the u to v dv, right? So by simplify, you have a mv minus mu. So we assume the force are constant, so that ft equals to mv minus mu. Okay, so this is the for part 2, right? Thank you. So now we proceed to question 4. Question 4. Okay. Okay, for the previous 3 questions, right, we always use the impulse, right? From question 4, we will use the conservation of momentum, right? If the momentum is conservation, okay, is conserved, we can use the law of conservation of momentum, okay? So the simple way will be m va plus mb vb is equal to MA UA plus MB UB. Right, the simple way you can maybe you can say M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2, right? So this equation direction is important. If you assume that go to right is positive, so always go to right is positive, okay? So that you can change the V, okay, positive and negative. If you assume that go to left is positive, so you need to change accordingly, right? So this is for the previous knowledge for question 4, right? So we proceed to question 4. Okay, for question 4, ball A of mass 0.5 kg traveling at 3 meters per second hits the stationary ball B of mass 0.2 kg. Okay, after collision, ball A is stationary. Draw diagrams showing the situation before and after collision. Okay, need to draw. And find the speed of ball after collision. Find the impulse of each ball. Okay. So normally, if the question never mention any have any direction, oblique or what, okay, any angle, I mean this is horizontal collision, okay. Okay, assume this is a horizontal collision, okay. So we proceed to part 1. Okay, part 1 question is ask you to draw before and after. I think the similar question will be in your trial exam, alright, but your trial exam with the angle, direction, angle. So this is a horizontal, you may direct draw. So before, after, okay, before you have A and you have B stationary 0, and A you have 3. Okay, and you have 0.2 kg and 0.5 kg. Okay, and after collision, you have A, B. Assume that this move in this direction. Okay, for A after collision, okay, you will have 0. Question mentioned. Okay, 0.4, 0.5 kg, 0.2 kg. Alright, so this is the first part. Okay, you need to show the velocity. If you don't know the velocity, okay, you just assume to the right. If you know, show it. Okay, if you know the direction, show it. If you do not know, okay, you may use something to represent. Okay, right. So we need to know which one is which one. So same things in your exam, please sketch it properly using a ruler because I see your actual exam, a lot of you did not sketch properly don't know how you sketch. Okay, anyway, so we proceed to part 2, right? Okay. Okay, for part 2, question is ask you to find the speed of ball after the collision. Okay, so same thing, you can apply the conservation of energy, conservation of momentum. So you have 0.5 after 0.5 times 0 plus 0.2 V. Okay, so assume that all move in the right hand side. Okay, so by simplify, you should get 0.2 V is equal to 1.5, and V is equal to 7.5. Okay, so you know that now B move to the right hand side with the speed of 7.5 meter per second. Okay, so sometimes the question will say B move away, right? Because A already stationary. It move away mean move the right side. If move nearer mean move closer mean move to the left hand side. Okay, so for this question will be move to the right hand side. by 7.5 meter per second. Alright, so now we move to part 3. Part 3, impulse for the individual item. So the impulse for A and B, you may use 0.5 times 0 minus 0.53. Okay, so you have an impulse 1.5 Newton second. Another one will be 0.2, 7.5 minus 0.2, 0, so 1.5 Newton second. Right, you can see that the impulse is opposite, right? So this one for part 3, 1.5, 1.5. Okay, both also 1.5. One is negative. For A is negative. For A is negative. For B is positive. Okay. So this is question 4, right? Okay, for question 5, before question 5, we need to use the coefficient of restitution, right? So when you have a coefficient of restitution, means this is under Newton's experimental law. Okay, so under this, okay, if you have a situation, this is a fixed surface, fixed wall, right? And you have a V hit on the wall and then repulse on this direction, Vs, separate, and this one is A. A will mean approach. Okay, the ball approach to the wall, hit on the wall, that is separate from the word Vs. So you can say that Vs, the separation speed is equal to E V A, right? So E will be the constitution, right? Coefficient of constitution, right? Under the Newton's experimental law. Okay. Okay. So let's say now is a fixed body. Another one is moving body. Now, if you consider both are moving body. Okay. So let's say you have before, after, you have A, you have B. Okay, move in this direction, UA, UB, okay, UB, okay, and after collision, you have move with this direction, VA and VB, okay. So same things, you can apply the experimental law. Okay, so you have VB minus VA. So this is equal to EUA minus UB, right? For this question, same things, we assume go to right hand side is positive, right? Right hand side positive, so we have this conclusion, right? This formula. Okay, right. So now we move to question 5. Question 5. Okay, question 5. Question 5, a direct collision takes place between the two snooker balls. The white cue ball traveling at 2 hits the stationary red ball. After the collision, the red ball moves in the direction in which the cue ball moving before the collision. The balls have the equal mass and the coefficient of restitution between the two balls is 0.6. Predict the velocity of two balls after collision. Right. Normally, before you start, maybe you can draw let's say you go to the left hand side is positive, go to the right hand side is positive. So you have Okay, so the white ball, the red ball, so u is equal to 2. Okay, and u equal to 0. And after collision, let's say, because never mention what direction, so let's say VW, white pole, red pole, and VR. Okay, before and after, same thing. So okay, so you can, if you want to solve this question, normally question is asking you to find the velocity, right? So normally you need to involve the experimental law and the conservation of momentum. Okay, so experimental law. Okay, clear first. Okay, so we can use VR minus VW. Okay, is equal to 0.6. Okay, 0.6, then UA U W minus U R, right? So this you can simplify 0.6 times 2 minus 0, right? So it's 1.2. So VR minus VW equals 1.2. So you can assume that they have the question is correlation. Okay, we assume that the question mentioned the ball have a equal width. So this is the first equation. Okay, we clear first. We go through the rest. Conservation of momentum. So mvw plus mvr is equal to muw plus mur. Right. Okay. So simplify and divided by m, you have VW plus VR is equal to 2, right? 2 only. Okay, so just now you have the experimental law, and now you have the conservation energy, the second equation. So plus the first equation and second equation together, you should get 2VR is equal to 3.2. Okay, so that you know that VR will be equal to 1.6. Once you know VR equals to 1.6, you can calculate for them from the equation 1 or 2. Right, you will get VW is equal to 0.4. Okay, so mean the positive mean the original assumption of your direction is correct. Okay, so after the collision for both move in the original direction of the white ball and the red ball at the 1.6. Okay, and the white ball will be moved with a speed of 0.4. So all move to right hand side. Okay, right, so this is for question 5. Okay.